just to review, so that this is public knowledge, I'm going to start over. I'm going to go over Unit 9 today. You should be. You should try to get finished with the Unit 8 assignment, which is number 6, this week, and then try to get this Unit 9 assignment done. Unit 9 talks about structural steel fabrication details. I'm going to show you some examples in a minute. But there's points to emphasize. One thing you need to remember is that fabrication details are an important part of shop drawings and must contain all information necessary so that the structural product detailed may be manufactured to meet the needs of the job. So that's why they're produced, is so that and it must have all the information that is there so that it can be built. In order to prepare these details, the drafter must have framing plans, the sections, and the connection details from the engineer. So that's the difference in the engineering drawings and the fabrication drawings. One thing you need to understand is the term shop drawings, as used in structural steel drafting. Shop drawings are fabrication details and bills of materials that provide shop personnel with all the information they need to manufacture the structural members of a job, ship the products to the job site, and erect them. That's what shop drawings are. And as an architect, if you go into architecture, you need to be able to read shop drawings and check them against your drawings and the engineer's drawings to make sure they're drawn correctly before they go out and produce the product. Fabrication detail, an important term to remember, as used in structural steel drafting. They are the orthographic drawings of structural members showing all information required for fabrication. And the primary component of a shop drawing is the fabrication detail, which is what you're going to draw with this assignment. The other component is the bill of materials, which we'll study in Unit 10. Let's see, the structural steel drafter, what must they have in order to prepare the details for the job? Like I said before, framing plans, sections, and connection details from the engineer. The fabrication detail contains orthographic views of the column, locational dimensions for plates, angles, and holes, length dimensions, base plate configuration, and connection specifications, and miscellaneous notes. And the beam has a little bit slightly different set of, some of the same, some different. They have orthographic views, sections or end views when required for clarity, length dimensions, locational dimensions for holes, angles, plates, cutouts, connection specifications, and miscellaneous notes for the fabricator. So one thing, in the, oh, I'm on the wrong chapter. Here we go. If you have your books, you can look on page 114, and one of the things they ask you to do is to examine figure 9-1 closely to determine how the actual member length of the beam and the hole locations were arrived at. So what you have on figure 9.9-1 is a fabrication detail drawing of some beams, and they want to know how did they get all that information, and that's what you have to study. On the other pages, figure 9.2, 9.3, those are the engineering partial engineering drawings that the engineer gave them so that the fabricator could draw these drawings. So you need to be able to look at these engineered drawings, which are figures 9.2 and 9.3, and understand how that relates to these shop drawings on figure 9.1. So that just goes, you need to be able to go back and forth and look at those. Some of these are kind of at a small scale. Did I put those on here? I think I did. Oh, what happened to my other pages? Oh, there it is. Oh, no, that's for the homework. I'll go over that in a second. So one of the things when you're looking at these, let me go back to this. looking at a column, how do you figure out the heights for a column, the actual heights, because it's going to be a little different. So what they're saying is you have your top of steel, and that's what I was trying to draw here. Then you have your foundation down here with your anchor bolts, and you have the base plate right there, and then you have your finished floor. All that's going to be dimensioned on those engineered drawings. And if you look on page 116, you kind of see it. You can see that information given to you there on those sections. So how do you?
On 118, the drawings is a little bit better.
Yeah, I mean that's exactly what I was.
That's what you have on there.
Yeah, and so I'm trying to. That's the formulas you need to follow, but it's basically what I'm getting at is that you got your top of steel to the finished floor plus that 9 inches is going to give you your steel length. Not, I mean that's the information you have to pay attention to. And on page 118, they do show you the little formulas. Floor line to the top of steel, floor line to the plus the floor line to the bottom of the base plate equals the total height of the column. So you don't include that built up grout or mortar between the foundation and the base plate. So does that make sense to you? And then the other thing I was going to show you was on the beam length. How do you figure out a beam length? They have that one. Oh, it's on 120.
On that last part, you're saying that the length of the column for the I-beam that you would cut would be the 12 plus the 9 inches would be how much you would have them cut the I-beam? Wouldn't you subtract the
I see what you're saying,
size of the base plate?
but what they're
If you submit this and they cut the I-beam at 12 feet 9 inches, your whole structure is going to be off that half inch or whatever that base plate is.
I see what you're saying, but they say it different in the book, don't they? Because they say the floor line to the top of the steel plus the floor line to the bottom of the base plate equals the total height of the column.
Yeah, if you look at figure 9-5,
9-5, yep.
the square tubing doesn't go to the top of steel, so then you wouldn't have those.
Well, that's a different scenario on this one. Column height.
Oh, okay, because you're connecting to the side there on
Yeah.
your drawing. But
Yeah.
you would still, on your bill of materials, you would still have to subtract that base plate. Otherwise, when you purchase your I-beam,
Yeah. What you're saying.
a half
Yeah.
inch or whatever the size of that base plate is.
What you're saying makes sense, but it contradicts what they say. So I wonder if there's a reason.
Okay, read the note on the bottom of 9-5. It says, note, total height of column achieved with 1 inch thick base plate welded to 10-foot 5 inch long structural shape. So they're subtracting that 1 inch base plate there.
Okay.
You see what?
Total, and on the other side, total height achieved with 1 inch thick base plate welded to 10-foot 5 inch. Okay. All right. I guess it's kind of like nominal and.
Yeah, you just have to remember for your bill of materials, that's what you would put there. The 10
Okay.
foot 5 inches, so that when they cut these pieces in their shops, they're gonna cut it to the right length, because otherwise you're gonna have an inch difference.
Right. That makes
And if
sense.
you're trying to fit this in a specific place,
Yeah, you can't have an
you
inch.
could throw everything off, because if you're doing a pipe rack and you're off by an inch, well then the pipes are gonna sit off of they're not gonna come out right.
Right. No, I get you.
Half an inch will throw off a big old monkey wrench and everything.
I know. That's why they have to be exact.
Yeah,
So.
but that's why we need to make sure. That's why you subtract that base plate.
But I wonder why they don't just do that from the get-go. It seems to be like it'd be simpler, don't you
Yeah.
think? Why do you have to have a note? Why don't they just say the column is total column height equals the top of steel
Top of base plate.
to the top of base plate, or to the floor line of the base plate minus the base plate thickness? I don't know. Anyway, y'all understand what you need to do then for that? Okay. So then for the assignment, I think that's for this chapter, which you need to get to work on. I reduced it from the original amount. Let me find that page. And it's on. It says this on Canvas for assignment 7 for unit 9, page 121. You're going to do number 3 and number 8. Number 3 says construct a complete column fabrication detail for column C1, and that's why I wanted to show you these. I scanned all these. I can't figure out how to turn them the right way, but anyway, these are the pictures from the book. That if you flip the page, it's all these pictures to the right. So I just wanted to go over these to make sure you're all looking at the same column when you draw your details, because there was confusion in the last time with some of the work. Who's here?
Three and what?
Who is that? Oh, okay. Okay, I'm sorry. So number 3, what did you ask?
Which ones is it? 3 and 6? Is that what you said?
3 and 8.
3 and 8.
So construct a complete column fabrication detail for column C1 in figure 9.9. So this page here, well, that's not 9.9. I thought I had 9.9. There it is. Okay, so column C1 is going to be this one right here. Wonder if I can draw on here. Circle. A. Column C1, they're referring to the column bubbles, and then this is 1. So this is going to be column C1 right there. Right? Does everyone agree with that? So you're going to construct a complete fabrication detail for column C1 on figure 9.9. And you're going to get, once you do it, it's going to look similar to figure 9.3 on page 117, I believe. I mean, it'll be that type of format. It won't look exactly like that, of course. Then, to get your other information for that problem, you will need to look at the other pages, and you get information here because there's column C in that section view, and then there's more information on the following drawings. I don't down at the this drawing. Sorry, it's sideways. It shows you detailed information of how those columns are connected, and you need to figure out which ones. So the other problem is going to be to construct a complete beam fabrication. This is number 8. Complete beam fabrication detail for beam B4 on figure 9.9. So B4 is going to be, just so that we all know, it's going to be this bottom one down here. B4. Okay? So then you need to look at the other drawings to get all your information, and your beam fabrication detail will be similar to what's seen on page 119. Okay? Is there any questions on that? Today we also, if you've read through chapter 9, I don't know if I'm logged into Canvas yet, but there's a quiz for chapter 9. So you'll need to do that, or for unit 9, sorry. So you'll need to do your quiz for unit 9, and then assignment 7, which is for unit 9. And then next week we'll go over unit 10. And as soon as we're through with Unit 10, we're going to have our first exam over the first 10 units. Okay? Depending on if we can speed things up, we may do that. That may be a take-home exam so that we don't have to spend class time doing it. But also in general, as a general announcement, Ms. Bennett and I met a while ago about attendance, and y'all saw my email or announcement last week. We're going to start trying to enforce that more and making a better, I guess, push towards people being in class, because even though this class is, what, 2.5 hours long, 3 hours long, you know, you're supposed to spend the time in here working on your problems while I'm nearby to help you if you have questions. It's not just to come do other stuff. And the same with all the other classes, studio classes. You're supposed to spend the time in the studio, etc. So, anyway, she told me to plug that, so I did. And so do quiz 9, quiz on chapter 9, and keep working on the assignments. It'd be nice if by next week we were all up to date on our assignments.